Hello guys, welcome back. This is Krishna again and welcome to my YouTube channel. So today I'm going to talk about one more activation function, and that is 10H. So why 10H? What kind of problem we were facing in sigmoid and softmax? So we will go through it one by one. So there are a lot of things which I'm hiding for now, but of course, once I will complete this activation function of a neural network, I will definitely let you know like what kind of other parameters are there, because I cannot tell you each and everything at once, okay? Because there are many things like why people start creating first sigmoid, then softmax, then 10H, then leaky ReLU, why they created so much stuff, right? People always create something when there are some kind of problem in the previous concepts, okay? So that's why I am not able to explain each and everything at once in a single video. So that's why I'm saying you to teach each and everything later on, okay? Once the appropriate time will come, right, to explain the stuff. So now in this session, I'm going to teach you about uh, activation function, and that activation function name is called 10H. All right, let's go to Google Colab Sheet then. So as you can see here, this is our activation function about which I'm going to teach you today. So let's copy this, scroll it down, and I'll paste it here. I'll make a note of it. And this is the part of activation function. So I'll simply mention here activation function, so it will be a bit readable to you guys. Activation function subdivision. So this is one more activation function subdivision about which I'm going to teach you. So I just want to show you something. So first of all, just keep one thing in mind. Like everybody will ask you in the interview why we use activation function. In that case, you guys have to answer like activation function basically use to get the complex pattern from the data set on which we train our model, okay? So suppose I have a huge data set, okay, and I want to get some pattern, complex pattern, using which in future, if I will ask any kind of question after training a model to that data set, I will get appropriate answer. For that, we have to do some mathematical calculation behind the scene, and their activation function play a crucial role, right? So activation function basically in single word help us to get the pattern from the data which we provide while training a model, okay? So this is the only use of activation function. Keep this thing in mind. This is very much important. In single statement, I'm repeating it once again when I'm writing this, just as a notes. So whatever activation function you have, the only uses of that activation function is to get complex pattern or learn complex pattern from the data set on which you are training a model. So activation function general definition is learn complex pattern from the data set which we use to train a model using neural network, okay? So activation function is simply used to extract or to get the pattern from a data set which we use for model training. Like let's say I have two classes. Last time I discussed about some fruit data set, right? So again, I'm talking about the same, okay? Let's say I have a, this is, you can say it is apple, okay? And this is, you can say, cherry, right? So suppose, see, behind the scene, you and all the other person can see this, right? And in our mind, there's something happened with our neurons, because our brain also made up of neurons, right? So in our neurons, there are some calculation happened. I know you guys will ask me, well, what kind of calculation happened? I never calculated anything. but you guys definitely did that. How I can say that? So see, whenever I see any object, let's say I have a banana, okay, I have a cherry, or I have apple. So apple surface is smooth, right? Whereas uh, its shape is also bigger as compared to cherry, right? Cherry are smaller in shape, apples are bigger in shape, all right? And cherry are smaller in shape. This is the first difference. So whenever we will get any data set in that some diameter mention over there of cherry and apple both, right? So these kind of thing we also calculate when we see any object, right? So when we see any object, we say this object is bigger and this object is smaller, like apple is bigger and cherry is smaller. So what we are doing, we are simply doing some calculation, and that calculation is being done by our brain neurons, okay? So that neurons basically help us to calculate, okay? Similarly, in machine learning or in deep learning or in neural network, you can say, such kind of calculation, such kind of neuron we create using mathematics. Neuron or deep learning is nothing but a calculation, okay, where we have two part, activation part and summation part, okay? So this is our neuron. It has two part. It has two part, summation part and activation part. So these are our input. Let's say I'm providing three input, x1, x2, x3. And this is what our output of single neuron, right? So what happened? It is something looking like our neurons, which is available in our brain, right? It's looks something like this, okay? It look, sorry. It looks something like this, okay? And this is just the covering of this, okay? Some sort of covering. So this is our neurons, okay? So here we have nucleus, means the brain of the cell, okay? So this brain basically have summation and activation part. Similarly, this is our neuron, which we create in laboratory or on computer, right? Using some mathematical algorithms, and that is called neural network. So we are basically creating neurons like this, which is working in our brain. Similarly, we are creating neurons in laboratory to do such kind of uh, operations in real world through using machines. So to teach something to a machine, we use this kind of neural network architecture. All right. So what I was telling you, like everybody's do calculation. Even I'm when I see any object, I first observe their texture, their shape, their size, right? And then I decide what kind of object is that. For example, if I have, let's say, this marker, okay, so I will say this marker is looking like a pen, but this pointed tip has no ink, right? So that means this is a marker, okay, which is used on which I'm using this on my digital board to write something, which I am using, which I draw this image, right? So using this marker, I'm simply drawing something. So my brain is saying to me, it doesn't have any ink on the tip, okay? So we cannot write it on paper using this, right? So this is a marker. We can only write using this on a digital board. Whereas I have one more pen, okay? So this pen has a pointed tip where we have ink, right? So this I can use to write something on a page, right? Or any notebook, right? So this is called pen. So what happened? This is just texture, okay? I just pointed two things here. It doesn't has ink of this digital pen, but this pen has something on the tip, and there are some ink also. You can see on my finger as well. See, my finger is a little bluish in color right now. So this is the only operation calculated by our brain, our neurons, and these all neurons means billion of billions neuron in our brain, okay? These all neurons come together, coordinate together, and help us to get any kind of decision. So similarly happen in deep learning. Now let's moving ahead, and I just want to tell you. Like we also provide some data set. Okay, so data set is nothing but we are providing some sort of data to some sort of differences. Like I told you now, this is a marker and this is pen. This is this tip is bluish in color, and it also has some ink, but it doesn't have ink, right? So these two are features. Similarly, if I will pass this apple and cherry, let's say, so this is our first feature, and this feature is talking about let's say width of fruit. Okay, and this is talking about height of fruit. This x2 is talking about height of fruit. So this is height, right? And this is width. This is w1, this is w2. This is height. Okay, this is h2, this is h1. So what it is, okay, this is simply we are providing some sort of texture shape, right, in the form of mathematical numbers, and that mathematical number we will provide to a neural network, and neural network will get trained. But hold on, I just told you about activation function. Without this, we are not able to calculate any kind of pattern from any data set. For example, let's say I have one, it is called cherry. It is all in inches, you can say. So it is like 3 and 3.5. This is, I will say, apple. Okay, and this is 2.5 and 3, I will say apple again. And if I will say 0 0.5, 0 0.6, this is cherry. So these data set I can provide to a machine, but only because of this, we are not able to get any kind of pattern from the data. Okay, if I will plot this data on a graph, because I have two features, x and x2. So let's say this is x1 and this is x2. If I will plot some graph, I will get some sort of values. Okay, let me make it a little bit in different color. Okay, so if I will use this is what, this is nothing but the equation of line. Equation of line means simple straight line. Up, suppose now suppose if I will draw a straight line, okay, right now it is easy to differentiate, but see, if I will draw a straight line, it is not able to differentiate these two classes into two different group. Now you guys will think, Krishna, if you will draw a line something like this, it is easier to differentiate. But I will say only with simple pattern, not with complex pattern. With complex pattern means, what is complex pattern? Okay, let me show you the complex pattern. Let's say I have some data points here as well, here as well, here as well. Okay, and I have some data point, let's say here, here. Now you guys will say like, Krishna, now how can we calculate it? Okay, so I will say their sigmoid function come in picture. Sigmoid function do what? See, this was your straight line which was splitting the data into two parts, right? But now this is not a much this is not now efficient to split the classes into two parts. Now this straight line which you have drawn here, right, which you have drawn here, is not able to differentiate your classes into two different groups. So in that case, activation function come in picture, and activation function simply transform the shape of line, and it transform the line and give the output something like this. Means the same line, this same line transform something like this. See, and we are getting two values. Okay, now you guys will say, Krishna, is it important to draw like this? I will say no, it can also be like this. Okay, see, two classes we are getting. This is my first class, this is my second class. All the data points are intact and split it into two parts. Now for these kind of stuff, we created activation function. And now activation function also have a lot of divisions, right? A lot of activation function we have. But why we have a lot of activation functions? Simple answer, because of need. if we will not face any kind of problem, then how we will produce a different kind of approach? We will never do anything, because without necessity there is no need of invention. Okay, so that's why people used to speak necessity is the mother of invention, right? So you guys, I already teach you guys about sigmoid. Okay, sigmoid. I I already taught you guys about softmax. Now I'm teaching you about what? 10H. I'm teaching you about 10H. So why these are important? So this is called, this is used at hidden layer. Hidden layer means hidden layer of neural network. Okay, I already taught you in the previous lecture. Please go through it. Okay, you will aware with this hidden layer. Okay, this softmax function we use at output layer or outer layer. Output layer or outer layer. Okay, outer layer. And this 10H we use again at hidden layer. So what is the difference? I would say, see, this is the image of sigmoid. This is the image of sigmoid. Means whatever straight line we are getting from here, if I'll use sigmoid function in this case, it will simply transform that straight line between 0 and 1. Okay, and 0.5, let's say, is the mid value. Okay, it always convert the all values between 0 and 1. Okay, now what 10H will do? 10H will do the same, okay, but little different. But a little different. Now what does that mean? Let me draw it. Okay, so see, now it will also transform the line, but that line should lie from -1 to +1, and this is the 0th point, okay, from where it is cutting the line. So this is the difference between the images. Now this is the difference of images only. Okay, this is not helpful to make me understand like what's going on, right? So what I can do more? So let me clean the windows first. Okay, okay guys, so I'm talking about the difference and the uses of sigmoid and 10H, because both use at hidden layer. Softmax never use at hidden layer, so I'm not taking softmax in this context. Okay, softmax always use at output layer. Okay, now coming on this, see, suppose I have a robo. This is a robo. Okay, who want to express some feelings. Okay, my robo is playing a game, a guessing game. Okay, let's say it is guessing something, any kind of number. Okay, and after playing that game, my robo want to show its expression. Okay, so suppose if my model train using this activation function, sigmoid activation function. So what is the range of sigmoid activation function? Sigmoid activation function between 0 and 1. So if my robo, let's say, very much excited, let's say, so it will simply show 1. Okay, like I'm very much excited. Okay, maximum value is 1. Okay, whereas 1 is for excited or happy. You can say my robo is happy, so much happy, so much happy. If my robo want to express this term, it will simply give me 1 as out. Okay, because it's trained on soft sigmoid, and sigmoid always return the value between 0 and 1. And if it is very much sad after playing that game, so it will simply say So it will simply say so much sad, or very sad. Okay, and it is saying 0. So there is nothing like any kind of feeling it can express, right, most of the time. And if we will train the same robo on 10H, let's say this time I am training, let's say I'm just picking another color. So let's say this is my another robo. Okay, I train this robo on 10H. Okay, so 10H range between -1 to +1. Okay, means whatever excitement, happiness I want to show, it can show between -1 to 1. So let's talk about it. Let's say again my robo is playing a guessing game. Okay, after playing that game, my robo become very happy. Okay, and that robo will express their feeling so much happy, so much happy, so much happy, using a number 1, let's say. If my robo is not happy after playing that game, it will say uh neutral. Neutral means he doesn't have any emotions for that, so he can express that neutral attitude by a value 0, because 0 is there. See, -1 to +1, that is the value. So 0 means he is neutral, he is not happy, neither happy nor sad. Okay, so to express the such kind of feelings, he can express using this number. Okay, now the last one is very sad. Okay, after playing that game, he become very much bored on that. Okay, so for that, what he can do, he will express that so much bored or sad, you can say, -1. So see, it is able to express the values very well. Okay, it is able to express things very well. Okay, he can express his emotions using various number. Okay, but in sigmoid there are two values. Okay, sad or happy. Okay, now I know there are a lot of possibilities. Okay, to get the output, but this example I'm giving to just understand, like if we have a smaller scale, if we have a scale, let's say between 0 and 1, if I will draw any graph using this scale, that graph will look very compact and will not very much clear. But if I will enhance the scale from -1 to 1, I will make the same graph little bit bigger, so that graph will be visible very much to us. All right, and that's why this 10H is much better than sigmoid in middle or hidden layer. Now coming on the formula. So what is the formula of this? So of formula of sigmoid, I told you yesterday, means in last class, and formula of 10H, I will explain you in this section. So the formula is not a big deal. Okay, that's just a formula which already introduced by someone. Okay, now you guys have to think to create your own formula, and for that you have to go through all the videos. Okay, so please go through all the videos. Now let me write the formula of this. So I'm talking about 10H. Let's talk about the formula of 10H. Before writing the formula of 10H, I just want to let you know I'm not talking a lot of important concept for now, because you guys are not prepared according to me. So that's gradient, which also fall in these activation function context. But to understand gradient, we should know first of all about the activation function, and that's why I'm completing activation function first. Once I will complete this activation function, I will teach you about gradients. All right, so 10h is nothing but e to the power z minus e to the power minus z upon e to the power z plus e to the power minus z. Now I already told you what is z. Z is nothing but summation part. Summation part. Okay. And it is also called as uh, equation of line. Equation of line. Okay. Equation of line. We calculate activation of these equation of line or summation part only. So this time my activation function is 10h. Okay, the activation function is 10h, which lies between -1 to 1. Means whatever value of z will occur. Okay, let's say my z value is 10, my z value is 20, my z value is, let's say, 1 lakh. Okay, so it all falls under -1 to 1. It will not go beyond that. Okay, it will not go beyond that boundary. So it simply help us to get the pattern and pattern from the data set on which we are training our model. Okay, whereas in sigmoid, I already told you about sigmoid. Sigmoid is nothing but 1 upon 1 plus e to the power minus z. Okay, this is the equation of sigmoid function. So this is the formula of sigmoid and it lies between 2 1. Okay. So let's calculate this. Let's do some mathematical operation and I will also make a note of it there. So now I'm going to mention some topic here, okay, which is important with this point of view. So 10h lie between -1 to 1. Okay, 10h graph shape is same like sigmoid, which is S shape graph. Okay, so these are few important topics which you guys have to remember. So most of the time people ask like oh, how's the graph of sigmoid look like? Is it look like any other activation function? Please name that activation function. Such kind of question they ask in the interview. So in that case, you have to tell them like, yes, 10h and sigmoid graph are same, but their range are different. Sigmoid range between 0 to 1, whereas 10h lies between -1 to 1. So I'm also mentioning about sigmoid lies between 0 to 1. Okay, so keep this thing in mind. Okay, now I just want to show you the graph, okay, using Python. So how can we create the graph? So first of all, I have to show you about some coding. Okay, I'm creating a 10h graph. Okay, so how to create a 10h graph. So I'm just assuming some hypothetical number and I will create that a hypothetical number. So what I have to do, I have to simply import numpy as np. Okay, so why I'm using numpy? Because I want to create some array. Okay, because I need a lot of data points on the graph. Okay, and that's why I'm importing numpy, and I will also import matplotlib.pyplot as plt. Okay, because I want to create a graph, so I will use matplotlib and numpy. If you don't know what is matplotlib and numpy, so please go through my playlist. Okay, and you will get the whole video on this and you can easily understand, because that's in Hindi language. Okay, so now import matplotlib plotlib dot pyplot as plt. Now I have to create a function okay, which convert my value. Let's say I have a value, okay, a is equal to 10. I want to convert it between -1 to 1 in using 10h, okay. So in NumPy, there is already 10h formula, okay. See, on the top, I'm getting 10h, okay. So I have to use this 10h, okay, and I will pass my a there, and I will print the whole value. I will get this value between 0 and 1. See, I'm getting this value between 0 and 1. Okay, so this is the use of 10h, but there are a lot of things behind, okay, and for that I have to create an array, okay. This is just to show you. So using NumPy linspace, I will create one array. I will say, let's say -5 to 5, and I need 10 values, okay. So this will start from -5 to 5, and I need 10 values, okay. And I will store it inside a variable called a. And just to show you like what I'm getting here, I will simply pass a here just to show you what kind of array I'm getting. So see, this is the array I'm getting on the screen, okay. Now I will create a function. I just need to convert all the values of a into -1 to 1, between -1 to 1. So for that, I need a function, and that function I will say 10h in capital. You can say anything, okay? 10h in capital, and I have to pass an argument, let's say, and np dot 10h, because that's the functionality there, and I will pass this argument. Now what will happen? So let's say I want to convert all the values between 0 and 1, and for that, what I have to do, I have to call this 10h, and I have to pass this a to it, okay, and I will store it in 10h values kind of parameters. And just to see this, what I can do, I can simply print 10h. I can simply print 10h value, and I'll get one more array. Oh, sorry, my bad. I didn't mention print properly. Was some misspell. So see, I'm getting -5 as, let me use the marker. So this is 5, -5. -5 get converted into closest value to -1. Okay, see, this is close to -1. This is also close to -1, but not as much closer as this one, right? This one is much closer. Then it is the second number closer to -1. Similarly, this one, these all values are from -1 side. Okay, now this value, these values are on positive side, towards +1. Okay, so see, as we move further, we are going towards +1. Here we have 5, so we are getting positive value, the same value like this. This is a negative value, and this is positive value. Now I want to create a graph just to show you. plt dot plot, and I have to pass my a and 10h val or value, the variable which I have used here. I'm passing that variable here, and this is my a, okay, which is the array, okay, which I am creating using linspace. Now what is the functionality of linspace? I forget to tell you. The functionality of linspace is it's simply split some value. Let's say my value is -5 to 5. Okay, so it will simply split all the values from equal interval. Okay, there is no mismatch gap. Okay, there is equal number of gap. Let's say here we have 0 0.5, 0 0.5, 0 0.5. So this gap will throughout the scale. Okay, so that's why we use linspace. Okay, now I want to plot this. I will label it, let's say 10h of x. Okay, x, this is only label. This is like a kind of label, like my name. Okay, that's a label. Okay, I will show you, just one second. And this is a kind of label you're getting on the screen, right? This is looking like s. Okay, Because we have lesser number of data points, it is looking something like this, like from this point, from this point to this point, we can see a straight line. From this point to this point, again we have a straight line, right? And it's all line joined together and give us a shape which is nothing but a S shape. Okay, so I just want to draw it first, then I will make it fine S graph. Okay, so don't worry. Now I want to make X label and Y label. Okay, so this is y-axis and this is x-axis. I want to write something here and here, so this is called label. I also want to write something on the top of this graph. Okay, so these are label and this is called title. These two are label and label, but this is called title. I explained these things in matplotlib seaborn series, so please go through my playlist. Okay, it's there in the deep in the playlist section. So let me draw it. So I will use plt dot label. Okay, it is X label. See, X label is this one. Okay, what I want to mention here, that is on X label. Okay, so I will mention, let's say data points. Okay, data points, or you can say this a value. Okay, this a value will lies on this axis. Okay, so I will mention it here a. Okay, see, I'll get, I think I made some mistake there. Yeah, X label. Let me make it smaller a bit. See, I mentioned here A, okay, on X label. So I'm getting A here, okay. Similarly, I want to mention something here. So what I want to mention, I want to mention 10 value, okay, because this is the value which we are getting on y-axis, okay. Why y-axis? Because I pass it on secondary position. So initially what I'm passing is on x-axis, and secondary value which I'm passing here is on y-axis. So I will pass this value on y-axis. So I will mention here plot, plt plot. No, not like this. I will mention here plt dot y label, and I will mention that values there. Okay, again if I will run this, I will get y-axis some values. Okay, see, this is that value 10 value. Now I want to give it some title. Okay, so I will mention here plt dot title, and I will mention 10h activation function. Now again you will see something on the top of this graph. See, this is on the top of the graph, 10h activation function I mentioned here. Now I want to create the value, the line, okay, which looks something like this. The solid line something look like this, and this line something look like this. Okay, so I'm going to create that line. How can I do this? Let's see. XH line, and on 0th point I want to pass line width. I mentioned about this. Okay, line width, let's say 0.5. I want to make the line width. Okay, and color, let's say I want to make it black. Okay, so I'll mention something like this. If I will run this, I will get something. See, this is that line which I'm getting here, which is going through x-axis. Okay, now plt dot, this is axv line, it is also going through 0 equal to, means I'm mentioning the color of this black, and line width is equal to 0.5. I'm saying you can mention any values there. Okay, so once I will run this, okay, it is running now. Okay, the shell is in under process. Okay, Let me run it again. So guys, see, I'm getting some sort of line here, okay? So this is something look like our 10H value. See, this is -1. See, this is -1 and this is 1. Okay, so our line started from -1 and goes up to 1. Okay, and this is all about 10H. If you really like this video, please do like, share, subscribe, share with your friend families, and go through my playlist. There are a lot of stuff to learn related to machine learning, AI, and give me a comment, subscribe. Thank you very much, guys. Thank you.